Okay, good afternoon once again. Today we're going to start our discussion on the main meat of this subject, which is multiple regression and time series. Okay. In the course of our discussion of multiple regression, we will have the chance to review some of the other statistical tests like t-tests, okay, z-tests, etc., that are related to our topic regression. And then after this, we will go to other forms of regression. We will have the opportunity to study a special type of regression like quantile regression, robust regression, logistic regression, because these are the new capabilities as far as regression is concerned. And then towards the end, we go to time series analysis. Okay, I'm sure you have had discussions of multiple linear regression in your other subjects, particularly your statistics. So by way of quick review, when you say multiple linear regression, you are trying to establish the relationship between your your response variable, which is your dependent variable, to that of your predictors, your independent variable or explanatory variable. If there's only one explanatory variable, then you have what we call a simple linear regression. If there are several explanatory variables, then we have multiple linear regression. Whether it's a simple linear regression or a multiple linear regression, the method used is, if you recall, it's called ordinary least squares. I hope you recall this. Ordinary least squares, OLS. So that's the method that's used in order to uh, determine the parameters, the values of the parameters. Okay, as I mentioned a while ago, in multiple linear regression, we would like to establish whether there is a significant relationship between your response variable, your dependent variable, and your explanatory variables. And we make use of this method OLS, as I mentioned a while ago, ordinary least squares. Okay, all right. Now, I wrote here, this is if you look at this very strange characters here, this is what we call LaTeX. This is the um, LaTeX codes. Okay, this is how you write. This is how you write special characters in a markdown file. So the result of this, if I enter this, okay, yeah, okay. So you have here the dollar sign, $2 signs, and $2 signs. So this is the beginning and the ending. And then you can see here that you have some text here. All right. So these texts were generated by this code above. So I'll just explain some of them. So you can see here that I begin with this slash beginning. So that's the beginning. And then you notice that it's aligned. Oops, Control Z. Align. And at the end, we have end and then align. So if you take a look at how this is printed, you can see that my text is aligned, okay, because of that code align. And then end. So this is where we start. You notice here that it's y and underscore I. This underscore is the symbol for uh, subscript. Okay, the underscore there, y underscore I means it's I is subscripted. If you can see here, diba? Naka-subscript si I. Tapos is equal to, then I have here a backslash beta. So to write the Greek letters in Markdown, you use this uh, backslash, forward button, backward slash. So beta. That's why you have here beta. This is in Greek, and then underscore 0. So you can see here, ba? Yeah, no? If I copy this, okay, so let me let me just write it here, Control V. Okay, if I want to have this printed here, I put $sign there. Okay, tinan nyo, di ba lumalabas siya, di ba? If I want to make it inline, just $sign. And tinan nyo, no? So it just will just appear here. Dollar, then kita nyo inline lang siya. For example, if I write here the character, the Greek character beta is written as, okay. If you notice, I have a sentence here, and then here, the $sign, it will write this one here. Okay, so these are just some tips on how you write your text, especially class, since in your case may group quiz, no? And then you will have to write equations like this, maybe some in Greek letters like this. So at least you know how this is done. Okay, so ito yung plus, di ba? Plus, tapos ito yung epsilon, nakita nyo? Underscore epsilon. Dapat pala may ano to. No? Yan, kita nyo? Epsilon underscore I. Tapos itong x sub I1, parehong ano to, no? These are both subscripts. Kaya nakita nyo, x underscore, and then we have here the curly brackets I1. Pareho sila kasing naka subscript. Alright? And then, notice here, I have two lines here, two backslash. Diba? It signals that the next one, ito ibig sabihin next line to. Ito. Next line. That's why here, you have here text, wherefore, diba, next line siya. Okay, so actually this is not a subject on LaTeX, but it's important for us to know how to write them also. Kasi may mga text kayo na kailangan din. Alright, so you can see here the formula for a multiple linear regression model. Y sub I is equal to beta null plus beta 1 times xi1, beta 2 xi2, up to beta n xin plus error term epsilon sub I, where for I is equal to, okay, I is equal to from 1 up to n observations. Siguro dapat ito, yi is equal to 1 up to n observations. Notice yung linagay ko dito, text 1 up to n observations. Yan, di ba? Yan. I is equal to 1 up to n observations. Alright, then y sub I is your dependent variable. X sub I are your explanatory variables. You have 1 up to n explanatory variables all in all. And then beta null here is your intercept, the constant term. Beta n are your slopes. Beta 1 up to beta n, depending on the number of predictors or independent variables. And then epsilon, the epsilon here, there should be an underscore I there, no? Is the model's error term, also known as the residual. Okay, so this is the equation. Okay, this is the equation for your multiple linear regression. Maybe in your previous subject, you only had one predictor. Ito lang, y sub I is equal to beta naught plus beta 1 x sub I1. So hindi na kailangan yung 1 dito kasi isa lang naman, x sub I na lang plus epsilon sub I. So that's what we call a simple linear regression because you only have one predictor. If you have several, then here you have n predictors, beta n predictors, and then it's called multiple linear regression. Okay, now it's important to understand that solving for the model is very easy sa R. Kasi simple lang yung yung function, LM lang yun. Okay, and maybe in other softwares also, sa Stata, ganun din. Sa Excel, madali lang din naman yung mag-generate ng regression output. However, we have to understand that there are certain assumptions that go with a multiple linear regression, and we have to know this. So what are the assumptions? Number one, linearity of the data. So dapat yung data natin linear. So anong ibig sabihin ng linearity of the data? What does this mean? Kita nyo, isang dollar, no, di ba? Lumalabas dito sa inline and linearity of the data. Nga lang may kailangan lagyan ko pa ng spaces. But anyway, all right. When you say linearity of the data, it means that there has to be a linear relationship between your dependent variable y and your independent variable x. Let me just put a space here and then let me draw something here. All right. So we would want that linearity of the data. So if this is your response variable y and this is your independent variable x, what we want is that the relationship between the two is as strong as possible linear. Ito linear siya, di ba? Yan. Linear siya. We don't want that y and x have this type of a relationship. Medyo quadratic, no? Parabolic. Yan. Whether facing this way, or facing that way, or facing downwards, or facing up, those are types of parabolic functions. No? And quadratic siya. So we don't want this kasi ang model nga natin linear. Linear regression tayo. So when the data, the relationship of x and y prove to be like this, then multiple linear regression might not be the good model. And it can be shown that if you try to model this type of a relationship between y and x, if you try to model it using linear regression, maraming mababiolate na policies ng classical linear regression model. Okay? So dapat, linearity of the data dapat. Okay, let me pause for a while. Is that clear, Counts? Clear ba yung linearity of the data? Is it clear? So sabi natin dito, the first assumption, relationship between the independent variable and the dependent variable can be characterized by a straight line. So dapat linear relationship niya. If it's not, then linear regression might not be, most probably is not the best model to establish the relationship. Okay? So sabi natin, the very simple way to know if there's a linear relationship is to use a scatter plot. I-plot natin si y at saka si x. If you can discern a linear relationship, then it's okay. Pwede natin gawin itong linear regression. Otherwise, as I mentioned a while ago, if the relationship behaves this way, hindi magandang ano yan. Kasi i-model mo siya na ganito. So this is not a good model if the relationship between y and x is like this. So dapat yan ibang klaseng model, polynomial dapat yan. May square or may cube and not linear. Okay, so another very important assumption, okay, this has to be met, is that the specified model to be linear in parameters. Now, iba yung linearity as far as the data is concerned. No? So this is the linear relationship between your y and your x. On the other hand, ito naman linearity of the parameters. Okay, let's take a look at how this plays out. What do you mean by linearity in parameters? Let me let me go down here. Okay, linearity in the parameters. So what does this tell us? It requires that the specified model to be linear in parameters, but it does not require the model to be linear in variables. Okay, what do we mean by that? Let's take a look at this. And tingnan natin to, ha? So you have here the equation y sub I is equal to beta naught plus beta 1 squared x sub I1, etc. Take note that beta 1 is not linear, squared siya. O pwedeng square root yan, okay? O pwedeng square root ng beta, okay? O pwedeng log ng beta, o pwedeng 1 over the beta. So these are not linear. Ang sinasabi sa atin, dapat yung linearity in parameters, yung mga betas natin, beta null, beta 1, beta 2, up to beta sub n, they should all be linear. So hindi pa pwedeng naka-log siya, hindi pa pwedeng naka-reciprocal siya, hindi pa pwedeng naka-square root siya, hindi pa pwedeng naka-square. So this is wrong. Well, hindi naman wrong, pero mahihirapan tayong i-model yan kapag may yung mga parameters hindi linear. Kunyari, naka-log yan, it will be difficult to solve the parameters. Mahihirapan tayo na ma-estimate yung mga parameters natin, mga betas. However, okay, may caveat. What's a caveat? It does not mean that, okay, take a look at this. It does not mean that hindi pa pwede yung mga variables ito. Kaya ito log x1, 2. Then ito square root. Square root of x1, 2. Okay. Alright, hindi pa pwede siya. Hindi pa pwede y. Because these are not linear in the parameters. So the parameters, okay, sorry, I stand corrected. These are okay. Okay yan, pwede yan. Kasi pag sinabi natin linear in the parameters, yung mga betas yun. So hindi pa pwedeng ilog yung beta, hindi pa pwedeng square yung beta na to, hindi pa pwedeng i-square, etc. Okay? The model might not be able to compute for the clear ko na muna. So, baka hindi ma-solve, no? So, ito pa pwede ito, naka-square root, si x1, i1. Pwedeng si xi2, naka-log. Tapos si xi3, naka-1 over xi to the in. So, pwede silang hindi, may operation sa kanila na which will make them, kunyari, log, square root, etc. But not the parameters. Okay? Not the parameters. Alright, number 3. Pause muna ako. Paki-chat please kung clear so far yung linearity. May linear relationship si y at saka si x. Secondly, dapat linear in the parameters. Waiting for the others' feedback. Okay. Alright, third requirement is homogeneity in residuals. Ano yung residuals? Okay, di ba ito yung ano natin? Balik ako dito sa, let me go back to another. Okay, ito. Okay, the regression model requires that we determine which of our predictors are significant. Sino sa kanila ang may K, no, para i-explain si y sub I? Okay? So sabi natin, di ba, we're trying to solve beta 1, beta 2, beta 3, etc. That's the objective. We want to compute for the parameters so that we're able to model y sub I and predict y sub I. We want to establish the relationship between your dependent variables and your independent variables and your dependent variable. So once we have run this model and determined the values of beta 1, beta 2, beta 3, okay, so na-complete na natin na-solve na natin yung mga values, and assuming they are statistically significant, so what happens now? When we have solved for these betas or parameters, then we can now compute for the what we call the predicted value, y hat. No? Okay, kunyari y hat sub 1, which is the first observation. Let's suppose si y sub I, yung actual value, ang actual value ni y sub I, y sub 1, first observation yan, is let's say 35. Ito yung actual value. Whatever variable y sub 1 is, no? Whatever variable y is. Can be age, whatever. Kunyari kung ano yung minamodel natin. Tapos nag-model tayo, na-compute natin si beta null, beta 1, etc. And then, we substituted it here. Kasi may mga corresponding x1 naman tayo, x2, x3. And so once we were able to compute for it, plus, let's say the value turned out to be 33. Okay? Ang tawag natin dito, this is your predicted value. Kasi ginamit natin yung betas, yung sinasolve natin, yung beta parameters in order to determine kung ano yung value ni y given this betas. So ang gagawin natin, i-compare natin itong actual na to, 35 yung actual, ang predicted natin 33. Okay, the difference between your actual value y sub I minus your predicted value y hat, this is now called your residual. Okay, E1, no? E1 kasi first, assuming na first value yan. Okay, so we will have a vector of residuals. So kunyari, meron tayong 100 yung sample natin, yung observations. So each one of them from y sub 1 up to y100 will have their corresponding predicted value. So yung predicted value na yan, pag i-minus natin sa actual value, we will have now our residuals. Okay, so what should be the characteristic of the residuals? Ano dapat yung characteristic ng residuals? Ang sabi dito sa natin, sa assumptions, the residuals should be, okay, dapat homogeneous siya. Homogeneity of the residual variance. Ano ibig sabihin ng homogeneity of the residual variance? Okay, i-present natin ha. Okay. Ano ibig sabihin nun? So, di ba na-compute na natin yung ano? Di ba na-compute na natin si y hat? No? Y hat is the, sorry, we have already computed for the residual epsilon, which is actual value minus the forecasted value or y hat. Okay, so epsilon yan. Epsilon siya. So, kung how much is your sample size, that will be the number of your residuals. No? Tapos pag plinat natin si residuals, dapat ganito yung behavior niya. Okay, so this is how your residual should look like. And what's the characteristic of this? Anong characteristic nito? Number one, okay, if you get the average of this, yung average niya, constant. No? Okay, so we should be saying here that the mean of the residuals, yung average nila should be what? Should be constant. Constant dapat. No? Constant dapat yan. So, yung mean. No? Now, ano ibig sabihin ng hindi homogeneous? Homogeneous means that our residuals behave like this. Hindi constant yung variance. Kunyari, pataas siya. You notice here, these are the residuals. Meron siyang tinatawag na fanning out. Habang tumatagal, yung variance lumalaki. So this indicates that the constant is not variance. The variance is not constant. And so we have, this is the opposite of homoskedasticity. This is what we call heteroskedasticity. Hetero. Pag sinabing skedastic, ibig sabihin yung spread ng residuals natin. So if it's heteroskedastic, it means that others spread to. Hindi siya constant. Okay? So dapat, in order for the model to be valid, we have to check the residuals. Are the residuals constant? Constant ba siya? Ibig sabihin, wala ba siyang trend na pataas o pababa? Kasi ito may trend to pataas. No? Or it just behaves along this bandwidth. Kung ganyan lang yan, okay yan. No? Kasi constant variance yan. Pangalawa, not only should the variance be constant, also the average, the mean of the residual should be constant. So yung mean niya, mean ng epsilon equal to k, constant siya. Tapos yung variance ni epsilon small e should also be equal to constant. So constant yung mean niya, when we draw a line here, hindi siya lumalayo dyan. Dyan lang siya sa bandwidth. Unlike kung hindi constant, lalabas siya dyan. May panning out or pag ganun siya, no? Pababa ganun. Panning in. Okay. And that's the opposite class of itong susunod. Okay, ito. Homogeneity, so heterogeneity, no? Ibig sabihin, hindi constant yung variance, hindi constant yung average niya, which we call heteroskedasticity. Okay? So, review na natin mga requirements. Number 1, dapat linear yung relationship ng independent at dependent. Number 2, dapat linear yung parameters natin. Linearity in parameters. Number 3, once we come up with the model, the errors, the residual should be homoskedastic. Constant mean, constant variance. Okay. Number 4, yung mga explanatory variables natin, okay, which are, sino may explanatory variables natin? Yung mga x's natin, dapat hindi siya collinear. Okay, what this means? This is very important. Okay. Clear ko muna. Okay, suppose, annotate ulit ako. Kasi sabi doon, di ba? Not related, no? Not correlated. So, paano nagiging correlated? So, meron kang isang x, meron kang isang x, no? So, tinitingnan natin dito parehong independent variables. And when we plot x and x1, example, tapos may nakita tayong relationship na ganyan. Ganyan. So, this tells us na may pattern siya, mukhang pataas yung trend. So, merong relationship. No? So, take a look at the slope m. So, there's a positive slope to this one. So, which means that x and x1 are collinear, no? They're correlated. Now, we don't want that. Ayaw natin na yung independent variables natin are correlated. Okay, that's why we say that dapat walang multi-collinearity. Hindi dapat correlated si x at si x1. Okay kapag si y at saka si x, maganda yun. So, ibig sabihin, y has the good explanatory power. X, sorry, has the power to explain y. Now, in this case kasi, si X at saka si X1, kung correlated sila, mag-aagawan sila sa pag-explain kay Y. So much so that it will become very difficult for us to determine ano yung kinocontribute, ano yung ine-explain dito ni X, ano yung ine-explain ni X1. Okay? So we don't want multicollinearity. Ayaw natin na yung mga variables na yan highly correlated. Kasi kung highly correlated sila, what does that mean? Okay, we will have difficulty determining anong variation ni Y ang in-explain ni X. Anong variation ni Y ang in-explain ni X1. Okay, so we don't want the independent variables to be correlated. But we want the dependent variable to be correlated to the independent variable. Okay, next. So that's the fourth, no? Dapat collinear sila. This is essentially the assumption that the predictors are not too highly correlated with one another. Multicollinearity exists when two or more explanatory variables, yung mga x's natin, are highly correlated. Bakit problema siya? As I said a while ago, just the last sentence, it's hard now to disentangle. Ano dito yung ine-explain ni X, ano yung ine-explain ni X1? Kasi masyado na silang correlated. Hindi natin alam kung which is which. Okay? It also suggests that the two variables may actually represent the same underlying factor. Kasi pwedeng si X tapos si X1, pwedeng si X1 just 2 times X. So may multiply mo lang si 2, makukuha mo na si X1, which is very wrong. Kasi bakit mo gagamitin parehong predictor yan? Kasi X2 na-generate lang via X1. Okay, so you normally, diba? Hindi mo sinasama dapat yan kasi highly correlated sila. Okay, number 5, independence of residuals error term. Actually, nasabi ko na po kanina. No? When you say independent, hindi correlated yung mga residuals, yung mga error terms. Kasi pag correlated dyan, okay, wala. Isa na tayo. Yan ang nawawala. Okay, independence of the error terms. Huh? Can you still hear me, class? Parang napuputol-putol ako.
Yes, sir.
Okay. Independence of the error terms. We don't want that as we said a while ago, okay, yung residuals sinitingnan natin dito, no? So we don't want the independent variables to be related. We don't want also the residuals to be related. Ayaw natin yun. Kasi pag related sila, ibig sabihin, the model was not able to capture. If we plot the residuals, for example, tapos ganito yung kakalabasan, ito yung X natin, ito yung Y, okay, ito yung residuals natin, epsilon, residuals. Tapos ganito yung behavior ng residuals natin. Alright? Ganito. So hindi independent yung residuals natin. They're still dependent on X pa sila. So ibig sabihin merong behavior yung variable natin na hindi pa nakaka-capture ng model. Alright? So that's the fifth requirement. Fifth assumption, dapat independent yung residuals natin. And lastly, the residuals should also be be normally distributed. Although hindi siya masyadong strict na requirement yung normally distributed residuals. Okay, quick review, no? Number 1, dapat linear yung relationship ng dependent at independent variable. We don't want that when you plot X and Y, halos ang correlation niya 0. Kasi hindi mo magagamit si X to predict Y if their correlation is practically 0. Okay, number 2, linear in parameters, which means that hindi pa pwede yung mga betas natin, yung mga parameters natin, hindi siya pa pwede naka-square root, hindi siya pa pwede naka-log, hindi siya pa pwede naka-squared. Okay, pa pwede yung mga independent variables, yung mga x pwede natin i-square yan, pwede natin i-log yan, but not the parameters. Okay, number 3, ano yung third constraint? Dapat yung residuals natin. No? So a lot of this has to do with the residuals. Yung difference ng actual value at saka yung model value natin. Okay, so ano daw dapat ang behavior ng mga residuals? Number 1, they should be homoscedastic. Dapat constant mean, yung average ng residuals dapat constant. Also, the variation of the residuals should be constant. Hindi pa pwedeng nagpa-fan out siya o nagpa-fan. Pangalawa, ano pa? What about the residuals? The residuals should not be interrelated. No? Dapat independent sila. Independent sila of the residuals themselves, and independent din dapat sila ng predictors natin. Right. Pangatlo, dapat yung residuals normally distributed. So tatlong condition ng residuals, actually apat yun. Tinitingnan natin. Number 1 is dapat residuals should be constant mean. Second, constant variance. Third, they should not be correlated, the residuals themselves, and also the residuals should not be correlated with the independent variables. Kasi pag may makita po tayong correlation between them, ibig sabihin yung model natin hindi na-capture yun. Dapat na-capture yung fact na yun that your residuals is related to your independent variable. Okay? And also yung normality ng residuals. Dapat normally distributed siya. Okay, so pause muna ako, class. Okay, questions so far? Pa-clarify naman kung clear siya or may questions. Okay, good. Okay, let me just get water. Sorry, class. Okay, thank you. All right. So I have here some references. May dalawa ko linagay na reference dito, but I'll just show it, but I leave you class to look at these sites. Marami pang ibang sites. I just gave here an example. Let me just flash that. So this is assumptions, or key assumptions of OLS, ordinary least squares, econometrics. Okay, so ito yung mga linear regression is linear in parameters. Yung sinabi natin kanina, hindi siya linear. Ibig sabihin yung mga betas natin hindi pa pwedeng naka-square o naka-square, etc. Random sampling of observations. Ito, conditional mean should be 0. No multicollinearity or perfect collinearity. Errors, dapat homoscedastic siya. And hindi dapat siya correlated with one another. And the error terms should be normally distributed. So practically, pareho dun sa diniscuss natin. Alright, and then it explains here the importance of this. Okay, ito the conditional mean should be 0. What does this mean? Pag kinuha nyo, class, yung average ng epsilon, no? Epsilon is your error term, di ba? It should be 0. yung average epsilon natin dapat 0. No multicollinearity or no perfect collinearity. What do you mean by perfect collinearity? Ano ibig sabihin tong perfect collinearity? Perfect collinearity means, lagay lang ako example na. Kunyari sa x1. x1 has kunyari values in 3, 5, 6, 1, 2, example lang. No? Kunyari years in that specific word. Ang x2 natin, ano yung x2? 6, 10, 12. Ano to? 12, 2, and 4. Alright, what do you notice about yung relationship ni x1 and x2? Anyone, please? Hello? What do you notice about the relationship between x1 and x2, class? Hello? Okay, pwedeng unmute na lang ha, para mas mabilis. Yeah, thank you. Yeah, you're correct. No? You derive x2 by multiplying x1 by 2. So 3 times 2, 5 times 2, etc. Ang tawag dyan, class, perfect collinearity. Okay? It's perfect collinearity. Now, bakit hindi pa pwedeng gagamitin natin si x1 at saka si x2 as predictors of y? Bakit hindi pa pwede yun? Okay, kasi, class, why? Kasi they're actually the same variables. So what will happen is that they will compete with each other to try to explain your y, your independent variable. And it would be now difficult for us to determine what part of the variability of y is being explained by x1, what part is being explained by x2. So, diba? Hindi natin malalaman yan kasi nga, they're perfectly collinear. Or even if they're not perfectly collinear, they are very highly correlated. No? So pag ganun, mahirap yun. Alright, so let me clear this. Okay. And some other, okay, ito yung example class no, ng residuals that are homoscedastic. Hindi constant yung yung mean. What do you mean hindi constant yung mean? Ibig sabihin nun, let me share again, annotate natin. If you take a look at this point, ito yung x natin to, no? At this point, the average of your residuals, ito, no? Pagdating naman dito, mataas na siya, malaki na yung variance dito. So, sabi nga natin, if there's a fanning out like this, across the values of your independent variables, ba? The variance is not constant. Dito, ang lalaki na ng variance. Dito, maliit yung variance. Alright? So that's what we mean by homoscedastic. Heteroscedastic. Same here. This is homoscedastic. And the residual should be homoscedastic. Okay, now, all of these assumptions have to be met in order for our model to be what we call the blue model. Ano yung blue model? What's the meaning of blue model? Best linear unbiased estimator. Okay, we want the regression model to be blue. Best linear unbiased estimator. And it will not be like that if there are violations in the assumptions of classical linear regression model. Okay? Alright, so ito class, so I would that you read this kasi it explains to us the importance of the of those assumptions. If those assumptions, ito sinabi ko class here, this one, ito, yung blue natin, here, blue. So if we violate the assumptions, then uh, our model is not anymore the best linear unbiased estimator, and we cannot rely on that. Hindi tayo pwede mag-depend or mag-rely on that for to explain your dependent variable or even to predict. Kasi minsan ang regression ang ginagamit yan, di ba, for predictive purposes. Okay, so let's continue para masabayan natin yung ano. All right, so here let me just let's okay. Dali. Ano ko na to? Let's use Pacman. We have learned already. Control F. Oops. Control F. Yan. Library. Find ko siya. Replace. Okay, tinanggal ko lang. Tapos, kindly insert a code chunk there. And then, we're going to, so let's first load si Pacman. Naalalin si Pacman. Library Pacman. Okay, this is a very good package for managing the packages. Control Enter. And then let's use the P underscore load. Okay, check nyo nga muna class bago nyo i-load. Kindly check if you have the site package or the paste text package in your package. Check nyo nga sa package dito kung meron kayong site, paste text, or OLSRR, or natin dito, Stargazer. Isama na rin natin si Tidyverse. Tidyverse. Si Tidyverse, unload na natin yan. Ito na lang, si site, si pastex, si OLSRR, Stargazer. Okay. And then we're going to make use of the P Pacman load, package load, which automatically installs the package if it's not yet existing in our computer and then loads it. So I find this very efficient kasi hindi na tayo mag-install that packages tapos hindi na tayo magla-library. Ito diretso na. Could you kindly check please if you have the Stargazer kung nasa package yun si Stargazer. Feedback please class. Do you have Stargazer sa packages yun? Go here, packages, and then type nyo sa search yung Stargazer dito sa search. Feedback please. Installed na for you, si Margaret, nag-ano ka na sa akin, di ba, dati? Yung mga hindi pa, class. Kasi for my previous students, nagamit na natin yan, yung Stargazer. For the others, si Jarod din, yung estudyante ko to. For the others, please. Ito si John. Okay, installing now. Sige. Thank you for those of you who have not yet installed this. Hindi mag-a-appear sa dito yan, sa package, di ba? But if you now use this one, yung preload natin from the Pacman package, automatically, if it's not yet installed, install niya, tapos ilo-load niya, and then if you look for it under packages, you'll find that it has already been checked here. Naka-check na siya, no? Even if hindi naman tayo nag-library kanina, di ba? O hindi naman kayo nag-install that packages. Automatic naka-install yan, naka-load pa. So that's I like that shortcut. Okay, and then kindly chat please if done na. Load yun na tong site, paste text, OLSRR, Stargazer. tidyverse, na-load na naman natin previously. Okay, we'll just quickly take a look at these packages. Alright, ano na ba, class? Na-load na? Kindly chat naman, please, kung na-load na itong mga packages na ito. Okay, good. Alright, so tingnan natin, ano ba yung mga use nito? Let's take, for example, always a good practice, class, to use the help function. That is Stargazer. Click ko to. So what is this? What is this package all about? Let's take a look at the description file. So this is well-formatted regression and summary statistics tables. Okay? So it will give us tables daw, magagandang tables. Kaysa yung mga ordinary looking tables na ordinary looking outputs, for example, regression outputs that are not presented in a good tabular form. Okay, so sino ang creator nito? Labak, no? Author Labak. And okay, version 5.2.3 siya. So maraming versions na rin yung so it enhances these packages. Okay? So back lang ako. And let's have an example. Konti lang naman yung mga niyan, codes, no? Ito, so Stargazer, tingnan natin. So the Stargazer command produces LaTeX code, HTML, ASCII text for well-formatted tables that hold regression analysis. Okay. Kuha tayong example. So ito, run examples. So we have this, tingnan natin to Stargazer attitude. Control C. Dito ko i-run para mas makita natin dito. Control V. Alright. Now, tingnan nyo to class, no? Ano to? What's this? Di ba parang yung kanina yan, di ba? Yung latex, di ba? It's in latex symbol. Ayan. Pero, let's see kung nasa viewer siya. Wala sa viewer. It's not shown in viewer. But if I copy this, copy ko nga to. Copy ko to. Dito natin ilagay nga sa ano. Let's put it here in the source window. Let's just check. Control V. Okay, and then gawan ko to ng $, and then $, dito. Kasi pag linagyan natin ng $, then enter natin. Okay, ayaw niya mag-run. Nag-run sa inyo, class? Okay, dito. Dito ko ilagay. Yung begin. Oops. Yan. Right, ayaw, no? Okay, anyway, so itong code chunk na to, may nag-chat, may nag-question ba? Okay. Actually, this medyo nabago na yung ano niya. Kasi dapat dati, automatically, magpiprint siya papakita sa ano. So, ayaw sa viewer. Ayaw sa viewer. Okay. dapat mag-generate siya ng output. Okay. Sorry, I can't, hindi ko hindi ko mapalabas. Parang ito kanina, di ba? Nag-LaTeX tayo. Ito. You can see this one. This is LaTeX itself. And then I'm just wondering why it doesn't, katulad nito, nag-run siya, di ba? Dollar tayo, $2. And then pag in-enter natin yan, lalabas yung equation. Okay, so this is what we do. Balik tayo dito sa packages. Okay, sa help. Okay. Tapos let's run it here mismo. Run natin examples dito. Let's run the examples here. Alright. So ito yung kanina, ito yung code, ano? Tapos ito pa rin, mga LaTeX pa rin to eh. Pero sa ilalim, let's see. Alam ko may example dito na ano. Yan, tingnan nyo to class. Take a look at this. Take a look at the output. You can see here the output to be a well-formatted table. So, kunyari, sa take-home exam nyo, no? yung first project natin will be multiple linear regression. So, let's say you have 3 models. So, how do you generate this? Kasi ito, model 1, model 2, model 3. How do you now put in a very good output yung tatlong models ito? Ito ginamit niya, Stargazer function. Linear.1, linear.2, and probe it. Tapos type is equal to text. Tapos may title to, regression results. Single.row is equal to true. Confidence interval, nagbigay siya ng confidence interval to, true. Okay, and then omit that stat, yung F, at saka yung, I think this is, sum of the squares ba? I'm not sure. Alright, so kita natin dito class, is in a good formatted table output. Tapos ito naman, this is another example. No? Probe it model, linear 1, linear 2. Okay, this is another example of an output coming from yung Stargazer. Okay, so that's just an example of packages that can give us good output as far as models is concerned. Ganon din class the same thing with si Psych, nagrepresent siya ng let me erase this. Si Psych naman, nagbibigay siya ng mga statistical analysis kasi this is for psychometric tests. Ang Psych, marami silang statistical test talaga na ginagawa. Okay. So I leave you guys to at least find out anong ginagawa ng ordinary least squares RR. Yung tidyverse kasi nakita na natin. No? So how about base text? Okay. All right. So now, how do we load data in R? There are several ways to load data in R. One way is to use this import data set. But for our purposes, hindi natin gagamitin muna yan. No? Later on, pag medyo sanay na kayo sa pag-code sa pag-import, you can use that. For now, gamitin muna natin ko lang to i-scrub ko lang to. Okay, parang malinis lang. For now, what I want us to do is to learn how to code. Now, take note, your data is already here. Nasa files na. Dito, no? So, yun siya, wage.csv. Now, we're going to use this code, read underscore. Okay, tingnan nyo, no? Read underscore, may CSV, CSV2, may chunk. Andyan din si Excel naman is read dot. Tingnan natin mamaya. Read dot x Read underscore XLS ba? XLS. Read dot X. Wala. X. Hindi ko makita yung read Excel, no? But there's a function called read Excel. I'm sorry, hindi ko makita ngayon, ha? Where is that? Tinataguan ako, ha? Underscore. CSV. Okay. Wait. Baka nasa ano siya? I think it's in another package, hindi ko pa naloload, no? Sige, never mind. Saka na yon. So, tingnan muna natin yung read underscore CSV. Okay, read underscore CSV. May CSV2 pa. Okay, so if I okay, ito yun, di ba? Read underscore CSV. I seek the help dito. So it's coming from the readr package. So it allows us to read a delimited file, both comma separated file and tab separated file into a table. So may mga examples tayo dito. Okay, so ito, no? Read underscore CSV. So you should have the CSV file. Read our example. Okay, and then, so there are several, okay, ano pa? Okay, yun na muna, no? Okay, so let's go now to our code. Isang oras. Import ano natin. So let's create an object called range. Alt minus, and then read underscore CSV. Wala. Okay. Read underscore CSV. So this is coming from the readr package. Ito. And then here you have, okay, anong file? Yung file natin, yung nasa na-load na natin dito. And then dito may column names is equal to true, column types is equal to null, column select is equal to null, etc. Maraming maraming pwedeng idagdag natin dun sa ano. But we'll just stick to the basic. No? So yung file natin naka-load na sa project natin. So the good thing about that is hindi na natin kailangan ilagay kung asan yung file location. Since it's already here in our project, we can just access this. So read underscore CSV, and data natin is wage.csv. Okay, and let's add some konti. So call names, may mga column names ba yan? Column names is equal to true. Okay, kasi may mga names yung ano eh. And then ano pa? Column select is equal to null. Ibig sabihin, wala tayong pipiliin na column, lahat natin isasama. Alright? Okay, so okay na muna yan, no? Alright? Okay. So we have this, read underscore CSV. Okay, normally, if we were not in a project, no, dapat hahanapin natin file location kung saan natin nakastore yung object. Kasi, yung file, kasi hindi mag-e-error yan kung ganito lang ilalagay. But the advantage of having a project and then loading your file there, diretso na. Kasi alam ni R kung saan niya kukunin yung file niya. Nasa project mismo. Nasa multiple linear regression project natin. And then call names is equal to true kasi may mga column names yung file natin. So let's run this. Okay. So, and then it gives us a summary. There are 528 rows, 526 rows, and 8 columns. So dito may sinasabi, tatlong character variables natin dito, race, gender, civil status. 5 yung double, ibig sabihin numeric, education, experience, etc. Okay? Alright, then may sinasabi pa siya dito, we can add more specification to this. Use spec to retrieve the full column specification for this data. Okay? Specify the column types or set to quiet this message. So pag linagay natin, show column types is equal to false, ibig sabihin hindi napapakita itong message nito. Okay, you can copy this, put this in the code here, tapos pag rinan nyo yan, hindi napapakita itong message. Okay, so let's run this. Rinan ko na, no? And then you can now see that you have the object here already. Kanina, andito yung file, ano? Pero kahit andyan yung file, kung hindi pa natin na i-import yun, hindi pa na magiging available yun. Now it's available. So tingnan natin yung yung laman niya. Alright, so there are 526 observations. Ito yung mga parameters, ito yung mga variables natin, education, experience. You have 1, 2, 5 numeric variables, and then you have 3 character variables. No? So let's check the structure of wage. Yan. If you recall yung structure function natin, structure ni wage, run natin to. Alright, you have this. Okay, so it's a data frame. No? If you recall a data frame, it's a special table, 526 observations by 8 columns. And then you have here yung wage, $, education, numeric, 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 si race character, si gender character, si civil status character. Okay, tanong ko lang, class, although we'll tackle that next meeting. Yung gender ba, yung race, do you think they should be classified into another type of character variable? How will they be more useful? Kung character lang sila? Class? How should they be treated? Kasi kung i-summary natin, summary wage, tingnan natin ha. Pag nag-summary tayo, you can see here that the variables, itong mga characters, no? Race, gender, civil status, length lang yung binilang lang. No? Binilang. Kasi tingnan natin yung ano ba yung class nito? Class ng wage. If I put the $sign here, lalabas yung mga variables. No? Ni race. Anong class to? Character lang siya, di ba? That's why nung sinamarize natin, binilang lang yung length. But it would be better for them to be converted into what type of data class? Please. Anyone? What type of data? Into a factor, no? Factor, di ba? Pag factor kasi, it will be treated as a categorical variable. Ibig sabihin, pwedeng pang-classify yan. Okay. So, it's almost time. Let me just show you here. Marami kami natapos kanina sa kabilang class. But, please, you know what this does, di ba? Yung view. Yung names ng data natin, diba? It will give us the variables. Names, wage. So there are 8 variables. And then yung tail and head, alam na natin yan. Just to subset. Structure, ginawa na natin kanina. It tells us it's a data frame. Then this one, we also run this. Class ni education. We know that it's numeric. Pero class ni race, that's character. No? Tapos yung summary ni wage, ginawa din natin. Alright. Now, dito, let me just show this to you. Para lang pareho tayo sa kabilang section. You can use the psych package in order to generate some descriptive statistics for our wage data. if I run psych, yung describe function niya, take a look at what happens. It will generate some measures ng descriptive statistics. Ito yung variables natin. Ito yung n, yung bilang niya. Mean, of course, yung mga to, yung may asterisk, wala namang, walang relevance yung mean nila dito, no? Kasi mga characters yan eh. Okay, pati yung gender at saka civil status. Standard deviation, this will only be relevant for the numerical variables. So that one we can use yung describe function ni psych. Also meron si space text, no? Itong stat.describe. Ang difference nito, okay, si stat.describe ng space text. Yung mga metrics niya andi dito sa rows. Tapos nasa columns yung mga variables. Baliktad sila ni describe. Pero at least dito yung mga characters ine-NA niya. Alright. And then we also have yung scheme R. Natin tong scheme R. Run lang natin tong scheme R. Scheme R package. Scheme. And then you have this descriptive statistics. Alright? Yan, no? Meron tayong a minimum, first quartile, second quartile, third quartile. Iba naman yung minimeasure nito. And then you have here yung merong histogram, no? Maliit na histogram dito sa scheme function. All right, so let's end there. Let's end there, and then we'll continue with this next meeting. Okay, sige. All right, class. Thank you so much for your patience. I'll see you on Thursday. No? See you.
Thank you, sir.
Thank you. Thank you all.
Thank you, sir.
Thank you. Happy Valentine's to everybody.